So everything's going along nice and smoothly with DHCP, and then all of a sudden we stick some routers in between our hosts that need addresses and the DHCP servers that will give them those addresses. And our nice clean process just got a little bit messy because routers don't forward broadcasts. And as we saw in the last video when we did the DHCP process walkthrough, the entire process is dependent on broadcasts. Broadcasts are like oxygen to DHCP. So to solve this problem, we need a little help from a command called IP helper address. And what this does, it allows the router to serve as a DHCP relay agent by changing some IP addresses. So if we're changing some IP addresses, you and I as network admins better know what's going on there. The helper part, that's where the help part comes in, because the router can take this incoming broadcast and make two major address changes to that packet. First off, the source IP address is changed to that of the router interface that received the packet. And in this case, I didn't number them here, but it would be this interface facing the host. So that's a little interesting. We'll see why it does that in just a moment. Here's what we're most interested in right now. The destination IP address of the packet is changed to the IP address of the DHCP server. So since that destination address is no longer a broadcast, the router can route it. Yeah, see what we did there? In all seriousness, that is a fantastic little command, and it really does help us out here. I'm going to show you exactly where you have to configure it, because this is a little real world versus theory note for you. I've seen plenty of networks that had IP helper address like on every Ethernet interface they ever had. And sometimes they needed it, sometimes they didn't, but it didn't really hurt anything. When you're working with OSPF in your CCNA studies, or you take that free hub and spoke course that I have on Udemy, there's a neighbor command that we have to use in a certain scenario. And while it's only really needed on the hub, I've seen plenty of configs that put it on the hub and all of the spokes. The reason I'm bringing that up is it really doesn't hurt anything in a production network to have that extra neighbor command or the extra IP helper address command. On your exam, though, you may be asked, make this work while putting this particular command on as few interfaces as you can. Because what they want you to do is not just demonstrate that you know the command, but also demonstrate that you know exactly where it's supposed to go and exactly where it's not really needed. In this particular network, we would only need it on the E0 interface on router 1. But it's very commonplace to see it on all router interfaces that face our local area networks. So again, the little real world versus theory note there for you. Here's the config of that. And it's simply IP helper address 172.23.23.100, because that's the IP address of our DHCP server. And again, let me bring the router up here actually and just show you. Now these are all the choices when you put in IP and then question mark. So we don't need to know all of these for the exam, thank goodness. But if we put in IP helper address, there really are no options here. Let's just say it was 172.23.23.100, and you can see that's the command, that's it. We really don't have any other options for it. So I've got that here for you on the board, and here are the source and destination IP addresses of a Discover packet as it comes in on Ethernet 0 of router 1. Well, of course, the source IP address of a Discover packet is always going to be what? It's always going to be all zeros, because this host does not have a source IP, IP address to use as the source. That's why it's going through DHCP in the first place. We also know that the destination address of that message is going to be 255 4 times. So the router here with the IP helper address command correctly configured is going to change both of those addresses. The packet source will become 172.12.123.1, which is router 1's Ethernet 0 interface. And the destination is changed to 172.23.23.100, the DHCP server itself. So again, we've got two changes in that scenario that we should be aware of. The source is all zeros, and here the destination is all 255s, and both of those will be changed by the router. Now, when the DHCP server replies with an offer, the router will see that the message is destined for an interface on the router itself, because the destination is now going to be 172.12.123.1. That's a tip-off to the router that this is a DHCP message that needs to be relayed, so it sets the destination address to all 255, and then it's relay away. That's it. So that's the entire process right there. And again, it's the IP helper address command, and while it wouldn't have killed anything if we put it on all the Ethernet interfaces on the router, get in a habit of just putting it on the ones where you need it, and that's facing the host. Now, in networking, of course, the solution tends to lead to another question. The question that a lot of you probably have right now is, well, what if I have more than one DHCP server on the network? What can I do then? Well, what you can do then, my friend, is configure multiple helper addresses. They do not, one is not going to overwrite the other. You can put more than one. Now, this option does allow communication from that remote local area network to both DHCP servers. But what I want to point out here, it's a term that if you're a newcomer, you might not have heard before, load balancing. Later on in the course, when we've got protocols that give us 2 paths or more between A and B, we may choose to use both paths or all available paths and do what we call load balancing. And that's so everything is theoretically supposed to get done a little faster that way, as long as your links are the same speed or roughly the same. And there's all kinds of fine-tuning that we can do to that. But the key is we're not just letting one path just sit there unused while the other path carries all the data. Now, the reason I'm bringing that up here is that this doesn't really balance the workload automatically when you put more than one helper address. It's not going to send half of the requests magically to .100 and then the other half to .120. To do that, what you have to do is start adjusting the delay values on those DHCP servers, and that is way beyond the scope of your current studies. And you're thinking, man, thank goodness we got enough to learn, right? But just keep in mind, it's great that you have more than one server there. You can use more than one helper address, but you're not doing any kind of real workload balancing there. We've got to leave something for you to look at later. Now, you'll see I have configuring DHCP with Cisco routers and then nothing after it, because I'm going to set up a lab with this. We're going to work with that a little bit, and I'm going to show you some basic commands on actually making a Cisco router a DHCP server. It's pretty cool. The syntax does take a little getting used to, but hey, what doesn't in this business? And we will jump right into that at the beginning of the next video. See you there.